Hello, this is Chuck Ridgway. It's Tuesday. It must be time for another technical topic. Our topic today is using the XLE as Ethernet IP remote I/O. So today's topic is another example of us trying to show you, give you a hint or show you a new technique for being creative to use some Horner products in a way you might not otherwise have thought of in order to solve a problem. Now, the problem we're solving today is that Ethernet IP I/O, the traditional stuff, is a little hard to come by these days. Lots of supply chain issues in the industry for sure. Now, joining me today is my colleague, Mr. Casey Gardner. Hey, Casey, how you doing?
Hey, not too bad. How's it going, Chuck?
Now, Casey, I have to admit, I've noticed a couple things today I've got to ask you about. Now, the first thing is, I haven't seen your lips move once yet. Did you go and join ventriloquist school or something, or what?
Yeah, I've been training for a while. It's going really well. I'm getting really good at it. But no, in all seriousness, we have a training class going on, and they're otherwise occupied in that room where I normally stream from.
Absolutely. We've got a class full of students, which is great to have. So, another thing I have to ask you about, and that is, you can't see this because you're joining us on audio today, but there underneath your face, the writing underneath there on the side there where I normally or remember seeing something like sales engineer, I now see product manager.
Well, surprised you can focus on that as opposed to my dead gaze in that image. But yeah, it's a title I've taken up recently. It's been nice to have, and I'm glad to be doing it for sure.
Absolutely. And congratulations. I'm really pleased, and I know that our products are in great hands. Okay, now for those of you watching live today, our product manager is standing by to answer your questions. Just chat those in. If you're watching this on replay, we still want your questions. Just give them to us in the comment section, and one of us will get back in touch with you. Maybe our product manager and maybe just me. All right, let's dive right in. Okay, here's how we've got our topic broken down for today. So first of all, we're going to answer the question, why would we use the XLE as an Ethernet IP remote I/O option? All right, so we'll get that answered for you. We're going to take a look at the available XLE I/O options because you need to match the I/O requirements of your applications with one of the models. We're going to give you some installation tips. By the way, or as you might expect, you're going to be maybe mounting this or applying this in a little different way than you normally would, so some tips are in order. And we're going to do something next that's a little different than normal. Here at Horner, we like to teach you to fish. We like to give you the skills you need to program your application on your own, on your own skill level. Today, we're going to actually present to you a pre-configured Seascape application that solves the Ethernet IP I/O application for you. We're going to take you step by step through implementing that, just using that with very little effort. And then when we're done showing you that, we're going to also, of course, tell you how it works. So if you decide you want to make changes later, or even if you just want to use it as is, you'll have an understanding of how it works. And of course, as always, we're going to have plenty of demonstration time today. All right, here we go. All right, why the XLE as a remote Ethernet IP I/O block? Well, as I mentioned in the opening, traditional Ethernet IP I/O is hard to come by these days. The XLE is popular and it's available. Now, that's not by accident. Our operations team, our management team, our ownership team, they have worked really, really hard to solve a lot of supply chain issues so we could continue to supply all of our Horner products, or at least as many as possible. And I think they've done a tremendous job during these trying times, and the challenges, of course, still remain. But you can get XLEs these days thanks to the hard work of those folks. Now, the XLE itself offers extensive I/O mixes that will fit a lot of applications. So that's another reason why it's a nice fit. It offers flexible mounting. Maybe you have used it in the past. If you have, you probably mounted it on an enclosure door, but there are other options, and we'll go through those. Now, sometimes we would look at an XLE and we'd say, the display on that product is a little bit old-fashioned. I'm used to nice color touchscreens, so you would see that simple display as a weakness. But for this application, that simple display is still great for showing I/O status for a block of I/O or a rack of I/O, far above and beyond what you'd normally get with just remote I/O. And then the fact that we're giving you this sample application file will make this a virtual plug-and-play experience to take the XLE product of your choice and to turn it into an Ethernet IP remote I/O block. So those are some good reasons to do this. All right, let's take a look at the different I/O options that are available for the XLE. Of course, these same I/O options are available for other members of the XL series family. All XL series family products, including the XLE, offer 5 different built-in I/O options. They range from the Model 2 that has a total of 22 I/O up to the Model 4, which has 40 I/O points. That's got the most I/O points. Now, let's talk about a couple of the most popular models. The Model 2, which is the one with the fewest I/O points, has been popular for a variety of reasons. It has 12 digital in, 6 relay outs. I think the relays make it pretty popular because it can be used with AC type outputs, for instance, but also with DC as well. It has 4 analog inputs that can be used for either 4 to 20 milliamp operation or 0 to 10 volts. Now, you also can get the Model 2 with a thermistor option. So if you've got thermistor temperature sensors, maybe 4 of them or 2 of them, those sorts of things, you can special order a XLE Model 2 with the thermistor option. Now, the other really popular model is the Model 6, and that one's popular not because it has 12 DC in and 12 DC out, which it does, but because it has 6 analog inputs and 4 analog outputs, and those are fully configurable channel by channel. On the input side, we're talking 4 to 20 milliamps, 0 to 10 volts, 0 to 60 millivolts, RTD and thermocouple sensors, and on the output side, we've got 4 to 20 milliamp and 0 to 10 volt options. And again, channel by channel, configurable the way you want. And all of these models feature high-speed counting capabilities as well. So really, finding the I/O model that meets your application should be relatively straightforward. All right, now let's give you some tips when you're installing the XLE as remote I/O block. Because remember, you're not using it necessarily as a controller, you're not using it as a user interface, you're using it as an I/O block. Now, an XLE traditionally can be mounted on the door, like a traditional HMI would be or a traditional OCS would be, but it also has been designed so it mounts really well on DIN rail. Okay, so that's more like a PLC, more like an I/O block. And if you're using it as an I/O block, that may be attractive to you. Now, another hint, and this is just for some folks, of course, you can, if you're mounting it on DIN rail, you can wire it like you would any remote I/O block with traditional wiring practices. But we've had some customers tell us that when they're DIN rail mounting their XLE, that they sometimes find it helps to pre-construct a simple wiring harness when connecting to the built-in I/O blocks to, say, interposing terminal strips. Sometimes they even make those using multi-conductor cables instead of just putting together, a ream of individual cables. Now let's also talk about cable gauge, because a lot of people tend to use conductors that are probably larger than they really need to be. 18 AWG is a really good size if you're using discrete conductors. It's easy to work with, and it's plenty beefy enough for just about anything you're going to throw at it from a signal standpoint. Even some, 2 amp or 3 amp, let's say, outputs from a Model 2 relay. Okay? Now, regardless of what model you choose, you're going to get removable I/O plugs. With Models 2, 3, 4, and 5, those are going to be screw type. With the Model 6, it's a pretty dense unit. By default, it comes spring clamp. Okay, now you can get screw type. It's a -602 part number extension when you order it, but spring clamp is standard. And if you are using the Model 6, because it's a lot more dense and the terminals have smaller, smaller cages and smaller springs, then you're probably going to want to use those 18 AWG wires. And if you're using ferrules, which I would recommend, make sure you use a flat crimper, okay? Because you're going to get a nice flat crimp that's going to work just like you want it to. It's going to stay when it needs to stay, and the wire's going to come out when it needs to come out. Okay, so that's my suggestion, some installation tips for the application. Now let's talk about this Ethernet IP I/O application, the actual application file or Cscape file that we are posting on the comment section today, and we'll make it available on our website and in other places as well. But basically what we've decided to do is to take all the guesswork and a lot of the work in general out of this application and just hand you an application file that you can quickly use with a minimum of effort to get up and running just as soon as possible. So let's talk about this application. Basically, it is a Cscape file that will turn any XLE model into an Ethernet IP remote I/O block. Okay, again, works with any XLE model from the Model 2 all the way through the Model 6. All the Ethernet IP configuration on the XLE side is all done. It's all pre-configured, nothing to do in Cscape whatsoever. It's also got customized user interface screens that give you all the information you need in terms of current status of all the inputs and outputs, even analog and high-speed counter. That's all taken care of with pre-configured user interface as well. And you can access all those, or your user can, at runtime to get all kinds of useful information in terms of what inputs are on and off and all those sorts of things. And then from a Cscape standpoint, the only thing you need to do is about maybe 1 to 2 minutes of hardware configuration on this one Cscape file, and then you're pretty much good to go. Okay, let's do a quick step-by-step. We'll run it through here on the slides, and then we'll show it to you with Cscape with a demonstration. Okay, so the first step, of course, is you need to select the XLE model that's going to fit your application's I/O requirements. We've talked about the different options available from the Model 2 to the Model 6 and in between. Just pick out the model that works the best for your application based on the I/O mix. Okay, then you're going to get a copy of this Cscape file that I've been talking about here. You're probably going to make a copy of it first. It's always good to keep the original tucked away. And then once you open that up in Cscape 9.9 Service Pack 6 or later, I created it in Service Pack 6, so you can't open it in an earlier version. My apologies there if you're currently using an earlier version. But once you open up the file, you're going to go straight into the hardware config. Now you'll find the file is pre-configured for a Model 2, but you're going to want to go in and set it for whatever model you're using. In my case, I'm going to show you that I'm going to be using a Model 6 here on my bench. All right, so once you've selected your model, you go into the local I/O tab, and then you're going to set the I/O details for the digital in, digital out, analog in, and analog out. Those are things like, are you using 4 to 20 milliamps on the analog side, or 0 to 10 volts? Are you using thermocouples or RTDs? Are you using high-speed counting? This application supports high-speed counting. So if you're using high-speed counting, you just need to configure that. And again, that process is going to take you maybe a minute, maybe 2, depending on your application. Okay, so once you've configured your I/O details, you're basically done. You want to save the file and then download it to your OCS. Okay, now as we turn our attention to the hardware, don't forget, if you aren't using the default settings for the I/O, if you're not using positive logic or 4 to 20 milliamps, then for the Model 2, 3, 4, and 5, you'll probably have some jumpers that you need to set, some physical jumpers. So don't forget that step. That's important. Okay, but once that's done, and of course you've downloaded your application in a previous step, now you're going to go ahead, install the unit physically, probably on DIN rail, okay? And then once it's all installed, you're going to go ahead and power it up. And then from the XLE keypad itself, that's where you're actually going to set up the Ethernet parameters, okay? And really all you need to set up there are the IP address and the net mask. I suppose there could be scenarios where you need to configure the gateway. Most cases that really doesn't matter. But you'll just need to, from the keypad, configure those Ethernet parameters. Okay, let's go ahead and show it to you using Cscape now. Okay, so here I am in Cscape 9.9 Service Pack 6, and I have loaded up this standard file that you'll find in the comment section and ultimately on our website and some other places. Okay, and as I mentioned, once this file's open, you probably should be working with a backup file, but once the file's open, you're going to want to pull up the hardware configuration and select your specific model. Now I'm going to be showing you the Model 6, so I'm going to change to the Model 6. Okay, once I've done that, it's just a matter of going to the local I/O tab. All right, under Config, Module Setup, now I've got my 4 different I/O types. I just need to make sure the I/O details match what I need. Okay, so under digital in high-speed counter, in my example, I'm going to leave it at positive logic, but I'm going to go ahead and configure totalizing for 1 channel of high-speed counting where I'm using the rising edge to count. All right, so that's my digital inputs for my case. I'm going to go to the digital outputs. Now, the digital outputs, there's usually less to configure here. In this example, this initial example application, I didn't do anything with high-speed output. So if you've got an application where you want to use the XLE this way as an Ethernet IP I/O block, but you need high-speed outputs, you let me know and we'll get another sample application sent off to you that incorporates that feature. But I left it out of this particular example application. So nothing to change here in my case for digital outputs. On the analog input side, this is a Model 6. I have 6 to choose from. I'm going to go ahead and configure a couple channels of 4 to 20 milliamp. Okay, I'll just leave the rest alone there. Okay, of course I would probably normally configure more than just 2 channels. And then on the analog output side, I'm going to go ahead and enable all 4 channels using 4 to 20 milliamp mode. Now the Model 6 happens to be the model that does not have any hardware jumpers, so setting it in Cscape is really all you need to do. I want the values to go to 0 if the controller goes out of run mode for some reason. The XLE goes out of run mode for some reason. So that's the I/O configuration that I want to use in my case. Yours is going to vary, of course, but that's all there is to it. Okay, I say okay, okay. Now I save the file away. I download the file, and what'd that take? 2 minutes? And I'm ready to go for using an XLE as an Ethernet IP remote I/O block. All right, let's head back to our material. And now let's start talking about configuring the other side of the equation. Now, for those of you who are, Rockwell guys who are very familiar with Ethernet IP and very familiar with configuring Ethernet IP devices, this may be second nature to you, but not everybody is as familiar. So we'll talk about how you need to configure the Ethernet IP scanner side to use the XLE in this fashion. Okay, so the first thing you're going to do is under the I/O configuration in your Rockwell tool, okay, your Logix software, okay, so under the I/O configuration and under the Ethernet network, you're going to add a new Ethernet module there. So right click and add a new Ethernet module, and then you're going to want to select from this big list that's going to pop up, you're going to want to select a generic Ethernet module. Now here's a hint. There's a million choices with this pop-up. So to narrow it down, you can use filtering. If you deselect everything except for communication devices and Allen Bradley devices, then the list gets a lot smaller and finding the generic Ethernet module is easier. Now, don't ask me why it's under Allen Bradley, because obviously a Horner is not an Allen Bradley, but that's where you'll find it. Okay, so you add the generic Ethernet module using those steps. Now it's just a little bit of configuration. This is really pretty quick. The first step is to name the I/O module, the Ethernet I/O module. Now I used XLEE as the name here. Now why does the name matter? Well, the specific name doesn't matter, but keep in mind that the name you give to the XLE in this dialog box is going to impact the tag names that get created later. So keep in mind what it is that you created, okay? I used XLEE in my example here. Okay, next you go to the COM format and make sure that double integer is set. So in this example application, all the I/O data that's coming to and from the scanner from the XLE is going to be in double integer format. And we'll go through how that's all set in a minute. Okay, next you need to fill in your connection parameters. The input assembly 100. That's the input assembly number. And then you need to fill in, if you're using the example application, 11 32-bit D words as your input assembly. The output assembly, which is assembly number 101, uses 5 32-bit D words. And then the configuration assembly number 3, that has a size of 0. Okay? Next, you need to configure the connection tab. And the important things there are the requested packet interval, which is kind of the update interval. I think the minimum is 10 milliseconds. You want to set that to a level that's appropriate for the amount of network traffic that you're looking for. You can certainly use 10 milliseconds, but you also may want to set it at 20 or 50, something that's appropriate for the application. And then you're going to want to make sure that unicast is checked. Okay, now let's talk about the tags that are created in the controller side of things, in the Rockwell side of things. Those tags are going to be based on the name that you gave the XLE. So in my case, I called it XLEE. So the tags based on my configuration and what yours should look like are effectively going to be a double integer array. On the input side, it's an array of size 11. So from sub 0 to sub 10. On the output side, it is a double integer array with the length of 5 from 0 to 4. Okay, so that's basically the tags that will be created on the Rockwell side of things. Okay, now let's take a look at the details within those tag arrays. Okay, so let's start with the input side of things. Now, the way I've set this application up, really, regardless of what model you've checked, the input array looks identical. Okay, the first D word has the bitmapped digital inputs assigned to it, followed by the 4 high-speed counter accumulators. Now, you may not be using high-speed counting in your application, or you might only be using 1 accumulator. No big deal. The ones you aren't using are just going to be zeros. Okay, so you just need to be aware of where they are mapped. Okay, and then following the accumulators, you'll have anywhere from 2 to 6 analog input values. Now, keep this in mind. On the analog input side, these are on the XLE side. The XLE reports analog values basically plus or minus 32,000 counts. But that data is going to be sent to the Rockwell as a double integer. So it's going to be signed properly and formatted properly, but the data, even though it's a double integer on the Rockwell side, is going to vary somewhere between plus and minus 32,000. Okay, so keep that in mind on the input side of things. Now let's take a look at the outputs. We've got an array of 5 double integer words, where the first word is the bitmapped digital outputs. Okay, so those are the real world outputs, and there's also 4 bits in there for clearing high-speed counters if you're using them. Okay, so that's in the first double word. And then the next 4 double words contain the analog data, anywhere from 0 to 2 to 4 channels of real-world analog data. Okay, and again, the data transmitted over Ethernet IP is double integer format. Okay, but when the OCS receives the data, it will convert it to an integer and then basically send it to the analog output channel. So on the Rockwell side, you're going to be writing a value between 0 and 32,000 as you scale your analog output from minimum to maximum. Okay, taking a closer look at those bitmapped inputs and outputs for digital I/O, for instance, and also keep in mind that even though we have 32 bits, obviously, assigned to each digital input and digital output, that the number that are actually used in real world terms is going to vary based on the model. Okay, now as I already mentioned, on the output side, output 17 through 20, the 17th through the 20th bits, so that's sub 16 through sub 19, those are used for clearing high-speed counters if you're using high-speed counters. And then the 32nd input bit, the very last one, that is used, or indicates, if you will, that indicates if you've had a short circuit on your solid state outputs. So if you're using an XLE with solid state outputs, which is the model 3, 4, 5, and 6, and that last input bit turns on in that first double word, you know you've got a short circuit. Okay, now let's give a demonstration of what this looks like on the bench. Okay, so here's my XLE, which is acting as an Ethernet IP I/O block. So you can see my main screen here. And this main screen, remember, I've got a Model 6. It's identifying itself as an XLE Model 6. In the upper right-hand corner is an OK LED. And it's filled in, which is good. That means the system is OK. And then we have 2 choices from this main screen, Setup and Status. Let's go ahead and go to Setup. And the only thing to set up really is our Ethernet parameters. So we can set up the IP address, the net mask, and then I suppose in some applications we may need to set the default gateway. You can see I've already configured these, so we'll go ahead and leave those alone. And I'll hit escape to exit out of here. All right, I'm back to the main screen here. Now let's go to the status side of things. And we have our choice between LAN status and IO status. Let's take a look at LAN status. All right, so on the LAN status side of things, we have 4 indicators. At the top, we have what's called link OK, and it's filled in, which is good. So that means that the Ethernet cable is connected, and I'm talking over Ethernet in general. So if for some reason the switch was powered down or the cable came unplugged, that link OK light would not be filled in. At the bottom, I've got Ethernet IP scanner OK. So that's filled in, which is good. So that means that my communications with the Ethernet IP IO scanner are healthy, also important. And in the center, it's probably hard to tell there, but we've got transmit and receive lights that are blinking away really fast because we've got a lot of activity happening right now. Okay, so that's the status information we have on the LAN side of things. Now let's take a look at our IO status. And most of the time, this is probably what we're looking at when we're looking at status on the XLE as an IO block. So I can go ahead and, as you can see, I make changes to the digital inputs. You'll see them change here on the screen as I'm changing them in my handy dandy IO simulator. You'll also see that on the far side here, in this first column, you'll see them changing on the XL4 I have there. Now, what's that XL4 doing? Well, this is our real-time automation Ethernet IP IO scanner. So this is doing all the Ethernet IP hard work, and then the XL4 is communicating using a different protocol with the IO scanner. So it's really just used as a display for this demonstration. Okay, but as you can see, as I manipulate digital inputs, you can see them turning on and off on the Ethernet IP side of the equation. Okay, so those are the digital inputs. Let's take a look at digital out. Of course, digital out is controlled from Ethernet IP side. I can manipulate those from the not over there. I can manipulate those from the XL4. You can see them changing state over here. You can also see them changing state on the display. Okay, so that's working as it should. On the analog input side, I have 6 total channels. 2 of them are currently active. So I can simulate those with my IO simulator. You can see the value is increasing up closer to 30,000. And you can see it reflected over here on the Ethernet IP side. I'll move it back down again. Okay, so that's all working as expected. You don't always get a lot of an opportunity to use an IO block that actually can give you analog values, for instance. That can be pretty handy. Okay, on the analog output side, again, that's controlled on the Ethernet IP side. Let's change this to 28,000 counts. Okay, and you can see that's reflected here on the display. Okay, if I had a voltmeter or something connected to, or a multimeter connected to my IO simulator, you'd be able to see it there as well. All right, and then finally, here's my high-speed counter. I've enabled it in this case. There's up to 4 of them. I'm only using 1. So as I increase my input pulses, they're being counted or totalized here on the high-speed counter demonstration status screen. Okay, and then when I'm done, if I ever want to go back to the main menus, I just use the escape key from any one of those status screens to go back to the main menu. All right, so there we go. That's what things look like at runtime with this Ethernet IP application. Now, I'll hit escape one more time to go out to the main menu. Now, one difference is that if you're using a Model 3 or a Model 4 or a Model 2, that will be reflected on the screen as well. Okay. Let's head back to our material and see what's next. Okay, well, the next thing we need to do, and really it's the last thing, is I'm going to go through the application and just show you how it works. Okay, not the bench stuff that I just showed you, but how is the application actually written. All right, so let's go ahead and get back into Cscape, and I'll kind of walk you through that. All right, so we're going to start from a little more details on the network configuration side of things. Okay, so I'm going to go back into the hardware configuration, but I'm going to go into the LAN section and show you that I have variables assigned to all of the LAN parameters. That allows me to set those from the screen instead of having to hard code them into Cscape or do something from the system menu. That's just the way to do it in most applications. So that made this application a lot easier and a lot more practical. Also, you'll see down here I have Ethernet IP checked, and from a configuration standpoint, I have assigned 22 words of data that is going to the network or to the Ethernet IP scanner. Remember, 11 double words is equivalent to 22 words. And then I have 10 words coming from Ethernet IP going to real-world outputs locally here on the XLE. And remember, 5 double words is equivalent to 10 single words. And then I have a status variable here so I can monitor the health of Ethernet IP. So that's kind of the basis of my LAN configuration. Okay, now let's take a look at the logic. We start with we've got 4 different sections of logic, and they're all really short and really simple. So let's go through them. Okay, we start with model ID. Now it made sense to have one application that can work with any XLE model. Yeah, we have to spend a minute or so in tweaking the configuration of the file before we deploy it, but that's really all there is to it. And maintaining one file is always easier to go. So what we're doing here is we've got a little bit of logic that uses one of the system registers. It reads one of the system registers, and based on a system register value, it can determine what model this program is running on. A model 2, 3, 4, 5, or 6. And that happens to be system register 133. The lower byte of system register 133 is an ASCII representation of the model number. Okay, so ASCII 2 is 32 hex or 50 decimal. So if we detect a 50 decimal, we know we've got a model 2, and so on and so forth. Okay, so that's the model ID detection section there, just one little section. All right, next we have a screen navigation section. So depending on which model we're using, or which model we've detected, I should say, we're going to jump to a different main screen a second after power up. So we detect that we've powered up, that it happened 1 second ago. We've already detected what our model number is. We switch to the main screen that's appropriate for that model. And we'll go through the screens in a little more detail in a minute. Okay, so that's the initial screen navigation feature. Next, we have a scanner OK section. Again, really simple. I showed you that there is a system register for Ethernet IP that we can monitor the health of Ethernet IP. Basically, how do we do that? Well, the lower byte of that system register, not the system register, of the status register. The lower byte of the status register, if it's greater than 0, it means we have an I/O connection established. Well, if we have an I/O connection established, it means there's an Ethernet IP I/O scanner that's controlling us, so the scanner is okay at that point. Okay, very simple. All right. Now, if the scanner is not okay, what do we want to do? Well, we want to put the I/O in a safe state, the outputs in a safe state. So we want to turn off all the digital output bits, Q1 through Q32, we'll just turn them all off. And for the 4 analogs, up to 4 analogs, we're going to go ahead and set those analog output registers all to 0. Okay, that'll put everything in a safe state if the scanner is not okay. So that's an important step. And then that OK LED on the main screen that I showed you, what is that? How is that different from scanner OK? Well, if the OCS I/O is okay, so no I/O faults on power up, and the scanner is okay, then we'll turn on or fill in our OK LED on the main screen. So that's how we generated that. Okay, last, all that we have to do, this is maybe a little complicated, but it's not really complicated. Next, we basically just need to map our digital inputs over to Ethernet IP and vice versa. Take data from Ethernet IP and map it to outputs. Okay, so let's go into, and to do that, on the input side of things, we really don't care if the scanner's okay to do the input mapping. We're just going to do it either way because it doesn't affect safety. On the output side of things, we're only going to assign the outputs if the scanner's okay. Otherwise, we're going to leave all the outputs at 0. Okay, so let's take a look at the subroutine I've created for assigning the inputs. It's also very short. Okay, first step is we need to take those 32 inputs, I1 through 32, and we need to send those out as the first double word over Ethernet IP. And the first double word we're sending out over Ethernet IP is R1 and R2 combined, because this is a double word function. Okay, so that's the first thing. Next, we need to move the accumulators for our high-speed counters. If we're not using them, oh well, they'll just be zeros, okay? So I have individually used D-word moves to move the accumulators, which are already double words, over to the appropriate double words on the EIP network. Okay, so that's the next section. Then the last thing to do on the input side of things is the analog input channels. Okay, so all XLE models have at least 2 analog input channels. So we map those over to the network. But remember, our analog inputs start out as integers, but we're going to broadcast everything to the network as a double integer. So that means we're doing an integer to double integer conversion here for each of the analog channels. We've got the first 2 channels that get sent out regardless of model. The next 2 channels get sent out for a Model 2 and a Model 6. Yep. And then the last 2 channels, 5 and 6, get sent out if it's a Model 6. So that's the logic that's required for taking input data of all the different types and sending it out over the network. Okay, now let's take a look at the logic that does the opposite. Takes data from Ethernet IP registers and assigns it to Q and AQ registers. Okay, here's the data coming in from Ethernet IP, this double word. We're copying that over to Q1 through 32. Okay, with a simple double word move block. And then all that's left is analog output data. Okay, so we're taking data from the network, converting from double integer to integer, because locally the analog output registers are single integers. And we're doing 2 channels for Model 5 and Model 6, because those both have 2 channels of analog output. And then the Model 6 has an additional 2 channels, which we are also copying over as well. Okay, so that's the application from a logic standpoint. Let me show you how I did the screens. I could have done the screens in a variety of different ways. This is the way I've chosen, just to hopefully make it so it's fairly easy to follow. Okay, we'll go ahead and take a look here at the screen. So these are the first group of 20 screens, and this is a screen that's shown on power up, okay, for the first second after power up. And then these are the screens that are associated with the Model 2. So if I'm running this on a Model 2, these are the screens that are going to show up. All right. This is the main screen that shows it's a Model 2. If I hit Setup, I'm going to navigate over to this screen. If I hit Status, I'm going to navigate over here, where then I can choose either to do LAN status, or I can choose to go to I/O status, where I start this run of consecutive screens here. Now you'll notice a couple holes, okay? There's holes here because for the Model 4, it has 2 input screens because it has 24 digital inputs. So the Model 4 has an additional screen here, which the Model 2, 3, 5, and 6 don't have, all right? There's another hole here, that's analog output screen. That's because the Model 2 doesn't have any analog outputs. So it's got a hole there as well. Now these arrows that you see, they're just kind of covering up, if you will, a jump button. Let me go ahead and hit the tab here until, I'll go the other way. I'll hit the tab until the jump button shows up. It's kind of buried behind that arrow key. Okay, so the jump button basically is going to be used to either go to the next screen or the previous screen. All right, now you'll notice this one says +2. What's that all about? If I go to the next screen, wouldn't I want to go to screen +1, or the previous screen, I go to screen -1? Well, remember, this is a scenario where the next screen is blank because we don't have any additional digital inputs. We just have one screen of digital inputs. So I can't do a +1 to go to the next screen because that one's blank. I have to, in this case, I have to do a +2 to jump to the subsequent screen. But then once I get on that subsequent screen, most of the rest of my jumps are going to be +1. Okay, and if it's a previous, then it's going to be usually a -1, but if the screen before it is blank, it's a -2. So that's really what's going on there from a screen navigation standpoint. When at power up, if I'm running this on a Model 2, it gets dropped off on this screen, and all the other screen changes are done with these jump buttons or jump functions, okay? And then I have a group of screens for the Model 2, for the Model 3, for the Model 4, for the Model 5, and for the Model 6. And you can see the only real differences are, you know, some of them have holes in different places because they have more I/O than other models do. So anyway, this is the approach I chose to take. I could have been more clever probably, but sometimes it's better to be a little more clear and a little less clever. All right, so that's how this Ethernet IP application works that you can use to turn your XLE into an Ethernet IP remote I/O block. Okay, so that's pretty much what I wanted to show you for today. Let me go ahead and bring in Casey real quick, or at least the image that represents Casey. So were you able to follow that okay? Anything I missed? Anything you would have done differently?
No, I think that was done pretty well. We had a couple questions come in, just looking for clarification on.
Okay.
One question was regards to the connection parameters and whether they would vary for any of the other models, probably from the Allen Bradley software side. And I believe that's a no. I believe it would be the same in terms of the connection for all of them.
Yes, absolutely. And I intentionally designed the application so that it had a consistent connection details. Even though obviously if you're using a Model 2, it doesn't have any analog outputs and it only has 6 digital outputs. So there's some, you know, zeros or ignored variables as part of the mix. Everything is consistent. It keeps it simple.
Yep. So in that case, it's going to be just the mapping that may vary for each of those. So in regards to that, we had another question that came in regarding the I/O OK and the scanner OK bits that you had for the application. Are those in the mapping provided as well?
They weren't. Okay. So, and of course, if you're not communicating with the scanner, you couldn't really transmit scanner not OK. Yeah. You could, of course, transmit scanner OK, but you couldn't transmit scanner not OK. And then from the standpoint of, what was the other question?
The I/O OK.
Oh, the I/O OK, right. That's one that I probably could have put in the mix, to be honest, and maybe I will in a future version. And it won't impact the size of the I/O map or anything like that. I'll just find a spot that's currently blank to stick it in there. But that's some good feedback. But maybe we'll put that in a future version.
All right, sounds good. I think that covers it.
All right, terrific. Well, thanks again, Casey. And once again, if you're watching this on replay, give us your questions in the comment section, and either Casey or myself or one of our other team members will be happy to answer your questions. Okay, a couple other things before we close. Okay, next week, our topic is using the Seascape menu object. So another way I could have done the screens on this XLE would be to have used the menu object, which I really contemplated, to be honest with you. It's a pretty handy way of taking a small screen that requires a lot of configuration in an application and organizes it clearly and makes it pretty easy for users to navigate. So if you're using smaller screens, maybe 3.5 inch or XLEs or XLTs, if you're using small screens, even bigger screens in some cases, if you've got a lot of configuration data, the Seascape menu object can be pretty darn useful. I also want to remind you, we're here every Tuesday at 2 o'clock. If we're not live in person, we're streaming live a pre-recorded video and somebody's standing by to answer your questions live, okay? And of course, you can always watch our program on replay to get the information you need, or to bone up on an opportunity or application once you've seen it the first or second time. Also, if you haven't done so already, don't hesitate to subscribe to our channel. It doesn't cost anything, and if you choose notifications, then you'll be notified every time we go live or every time we post a new video. Okay, well, things are trending in the right direction from a pandemic standpoint. Let's hope they keep continuing that way, but until we know this thing is completely over, everybody stay safe out there. Take care.